chapter 4.2, dealing with laws of exponents. Here is a very, very important section that I find a lot of students coming out of Algebra 1 are not proficient enough in. And so it's always important to reiterate that you put the time in, figure these things out, that you do it so much. If we look at the first law, that's multiplication. Well, that didn't take long to not work. That's not a good thing. So we will try to reopen that, hopefully. This is back-to-back times that this hasn't worked. Didn't work a little bit earlier today. Well, we're going to do this process. And what a great way to open up the video. Is it not working? So we're restarting the smartboard. If you're wondering what I'm doing, but if you're not proficient in Algebra 1 and you know it inside and out, and I mean inside and out, not just the most basic stuff, not just the stuff that is produced to you, provided you in class. You have to go above and beyond, and you have to do things, doing every single word problem, every single practice problem. If the teacher gives you odds, you should be doing the odds and the evens. You can't be proficient enough in algebra. It is so important. And in order to be successful in Algebra 2, you have to be proficient. So the first law is the law of multiplication. When we multiply like bases, we are going to add their exponents. When we have a power of a power, we are able to distribute that exponent into the parentheses. Typically, you don't distribute across multiplication, but when we're talking about exponents, you can. And then, we can distribute, and then when we do have exponents, what do we do with the exponents? We multiply their exponents. So we see these examples, they both have the same base, so we take their coefficients and we are going to add those exponents, and that gives us a to the 7th. When we have an exponent out here, we can distribute it to both of the terms inside. So you notice that the squared is distributed to both of the variables inside. And then when we have a power of a power, we are going to multiply those exponents. So one of the things that I always like to show is the reason. And so this is the theoretical reason. And then when we have a to the 3rd times a to the 4th, we need to understand that that's a times a times a times a times a times a times a. So we have 3 a's multiplying 4 a's. So how many do we have a total of? Well, we have 3 plus 4, which equals a to the 7th. When we have a squared b to the 3rd to the 2nd, we're going to distribute that, and that becomes a to the 2nd times 2 and b to the 3rd times 2. Because think about it, we have 2, this is the exponent, this is the exponent, and this is the base of the exponent. So technically we have 2 of these things. So we kind of have a squared b to the 3rd times a squared b to the 3rd. We have 2 of these bases. And so we have a to the 2nd plus 2, because we have multiplying like bases, we add exponents. And then we have b to the 3 plus 3. Like bases, we add their exponents. And so 2 plus 2 is just like 2 times 2. So it's a to the 2 times 2, b to the 3 times 2. And that gives us a to the 4th, b to the 6th. So keeping in mind that, and That's kind of important. That's what we're going to do. So here we're just multiplying. Those exponents are not outside the parentheses. When we multiply, we're going to multiply their coefficients, which is -2 times -3, which is 6. Oh, there it is right there, which is 6. And then we are going to, since we are multiplying like bases, you have x to the third, x to the second. And we're going to add those exponents. And then you have y to the second times y. And that's 2 plus 1. When we have this, we're going to distribute it out. So we have p to the fifth to the fourth. Whenever we have a power, we multiply. And then we have q to the 1. That's not a good notation. It should be. I'd like to see that as q to the first to the fourth. I'd like that to look like that, which equals q to the fourth. But this is a tricky one, coefficient. So when we have coefficients, if you have 2a to the third, b to the second to the third, you're going to distribute that to the coefficient also. So that's 2 to the third, a to the 3 times 3, b to the 2 times 3. 2 to the third is 8, a to the ninth, b to the sixth. That was a horrible b. So in this case, there's an invisible -1. I like that. And then we distribute that 3. Notice it's in parentheses. And -1 to the third is -1. You have 2a to the second to the third, which is 6. These are good questions, good examples. Should pretty much, we have like bases. So we are multiplying. We have a to the 3 plus 3. And that's where it gets important. Students recognizing the difference between the situations when they're adding and when they're multiplying, or you'll see in the next section when you are dividing also. So like bases must have like bases, c to the sixth. If they weren't like bases, for instance, if we have c to the third times d to the second, these are unlike. So it's just c to the third, d to the second. A lot of students will say cd to the 3 plus 2, cd to the 5, which is absolutely wrong. That's the mistake I see students making. So recognize this is a power of a power. We have a power and a power. So we have this outside exponent that has a base of that. So we have, technically we have 3a to the thirds. We have 3 of these. 1, 2, 3. That's why it's that quantity of the parentheses or Chewbacca. And so we could look at it in this sense that we're multiplying like bases. So we would just add their exponents. But that's very time consuming, and it's much faster to just know that when you have a power of a power, you're going to multiply those exponents and you get it like that. So 2 ways. It's good to understand what's going on. We have again power of a power equals c to the 8th. We have a power of a power, but this time we have 2 things. We have m to the first, n to the second to the fourth. This is the other important difference, knowing that you can distribute across multiplication when we're talking about exponents. That's m to the first times 4, n to the second times 4, m to the fourth, n to the 8th. And doing it this fast and efficient, recognizing, knowing the game plan, seeing and not thinking is going to be important. So we have x to the 10th, y to the 15th. You have to be able to recognize. Now, this is an interesting problem because notice this exponent. What is the base of that exponent? The base of the exponent is just x. The only thing being cubed is x. 5 is not being affected by that cube. So in reality, we have this. That's what that statement is saying. And if you want to even get more broken down, it really is doing that. So you're multiplying the 5 times 2, and then you have x times x times x times x times x, which is x to the 5th. But this is very inefficient. The way that you should be looking at that problem, when you see 5x cubed times 2x squared, you should just be looking at coefficients and then multiplying like bases. We are going to add their exponents. So you should just hit it like that. Coefficients, -12, like bases that are being multiplied. So we add their exponents, -12r to the 13th. So here you need to make sure that you understand that there's a -1 there, and that square goes out to both of them. Very important that you write a parentheses. And that's 5 times 2. So -1 squared is 1, and we get r to the 10th. Same thing, you're distributing that 5th power, -1 to the 5th, times x to the 2 times 5. This time we get -x to the 10th. Any negative number to an odd exponent is always going to keep its negative sign. In the problem prior, we had a negative to an even power, which will create a positive solution. Notice no squaring outside of the parentheses. So we're just multiplying 4 times the coefficient, which is 1. So 4, we have b to the first, b to the third, 1 plus 3, and d to the 2 plus 2. So our answer is going to be 4, b to the 4th, d to the 4th. A lot of 4s there. Coefficients, -12, like variables being multiplied, m to the 4 plus 1, n to the 3rd plus 1, -12, m to the 5th, n to the 4th. Now we have 3 terms that we're multiplying. We have this times this times this, coefficients. Negative times negative is positive. We have p to the 3rd plus 1 plus 2. So each of those exponents above the p, 3, 1, and 2. And then we have the q's, q to the 3rd, q to the 1st. So that's q to the 3rd plus 1, which is p to the 6th, q to the 4th. And the coefficients, -1 times -1. So we have 4 times 3, -12. We have r to the 4th, r to the 1st, r to the 1st, 4 plus 1 plus 1, s to the 2nd, s to the 3rd, s to the 1st, 2nd, plus 3 plus 1, -12r to the 6th, s to the 6th. All right. Now they get a little more complex. You have multiple things happening here. Looking at these examples, you have r on the outside. You've got this squaring of this base, and then you have r to the 8th, which is outside of that. So you would have to take care of this portion. We're going to do exponents, as you see, and then we would add those. So that's nice. This one, we're going to have to distribute everything prior to doing anything else. We're going to distribute it out to all 4 variables, or all 4 bases. This is a base, this is a base, this is a base, this is a base. And notice each one gets that cubing. So we, on this last one, we would have to cube that term, and we would have to square that term. So you're seeing the simplification of that exponent, and then you're dealing with that, and then you are going to simplify those two, that product, shall we say. So we're starting off relatively simple. We're going to distribute that cube to each of the things. That's 2 to the third, t to the fifth times 3 because it's a power of a power. 2 to the third is 8t to the 15th. You should know your cubes pretty much. We're going to distribute 3 to the second, s to the 6 times 2, which is 9s to the 12th. Distributing, we have a whole bunch of things. 3 to the second, x to the 1 times 2, y to the 2 times 2, z to the 1 times 2. That's going to be 9x squared, y to the 4th, z squared. Now that's pretty fast. I mean, you should see what the pitfalls are. You know that negative one needs a parentheses. That a to the first times 4th, b to the first times 4th, c to the 3 times 4. This is going to give us positive 1, a to the 4th, b to the 4th, c to the 12th. We're distributing to each of the pieces quantity because there's a negative. R to the 3 times 3, s to the 1 times 3, t to the 2 times 3. Negative 2 to the third, it's an odd. It's a negative number to an odd, so it's going to keep its negative. R to the 9th, s to the 3rd, t to the 6th. This shouldn't be a problem for any Algebra 2 student. And the fact that this is being introduced in Algebra 2 is kind of comical. So you have 6 squared, c to the 2 times 2, d to the 4 times 2, e to the 5 times 2, 36, c to the 4th, d to the 8th, e to the 10th. We have to cube first. This is a good one. Attention to the details. So we have to cube first. So we actually have negative m squared, and then we have negative 1 cubed times m cubed. So we have to simplify those exponents. Negative 1 to the third is negative 1 m to the third. Now we can multiply the coefficients, which is 1. We have m to the second times m to the third, m to the 2 plus 3, m to the 5th would be our final answer. All right, those exponents are inside this time, so we just have coefficients. Negative 1 times negative 1, z to the 4 plus 2, z to the 6th. We have an exponent outside, so we got to deal with that. All those other exponents are inside, so we have negative t to the third, negative t to the 4th, then we have negative 1 squared, t to the 2nd. So those negatives, well, let's simplify, let's be consistent. Negative 1t to the 3rd, negative 1t to the 4th, negative 1 squared is 1 times t squared. Negative 1 times negative 1 is positive 1. We have like bases, so we're going to add those exponents, and that is 7, 8, 9, t to the 9th. Oh, 2 outsiders. So that's outside, that's outside. Another one is inside. So we have negative 1 to the 3rd times a to the 3rd times negative 1 to the 5th times a to the 5th times negative 1a to the 4th. This gives us negative 1 times a to the 3rd. This gives us negative 1 times a to the 5th times negative 1 times a to the 4th. Negative, negative, negative gives me negative. We have like bases that are being multiplied. That's a to the 3 plus 5 plus 4, which is negative a to the 12th. 2 exponents in this one. We have a cube for this term, and we have a square for this term. So you have 2 to the third times r to the 2 times 3, power of a power. We have 3 to the second times r to the second. That's going to give us 8r to the 6th times 9r to the second. 8 times 9 is 72. R to the 6th times r to the second is r to the 6th plus 2. 72r to the 8th. We've got an exponent, and to this term, we have an exponent to this term. I'm liking these are fun. 5 squared, k to the 4 times 2, 2 to the 4th times k to the 4th. That's 25k to the 8th times 16k to the 4th. 25 and 16. What's that, 400? 400k to the 8 plus 4, or 400k to the 12th. Pretty sure there's 4 sets of 4s in 16. 25 times 16. 400, yep. I thought of them as dollars, quarters. That's how I think of 25s. That's that exponent to that base, that's that exponent to that base. You have x squared times y to the 2 times 2 times x cubed times y cubed. X squared y to the 4th, x to the 3rd, y to the 3rd. Like bases, you're going to add their exponents. Like bases, you're going to add their exponents. X to the 5th, y to the 7th. All right, this is good. Keeping track, knowing how to distribute efficiently, yet accurately. G to the 3 times 3, h to the 1 times 3, negative 1 to the 3rd. We have g to the 2 times 3, h to the 2 times 3. G to the 9th, h to the 3rd, times negative 1. G to the 6th, h to the 6th. So we get negative g to the 9 plus 6, h to the 3 plus 6. Negative g to the 15th, h to the 9th would be our final answer. And look, we love having to do 29 problems. More practice means more better. Math teacher. 4 squared times x to the 1 times 2, y to the 1 times 2, negative 1 to the 3rd times x to the 1 times 3, y to the 2 times 3. 16 x to the 2nd, y to the 2nd, times negative 1 times x to the 3rd, y to the 6th. 16 times negative 1 is negative 16. X squared times x to the 3rd plus y to the 2nd plus 6. Negative 16, that's a big negative right there. Negative 16, x to the 5th, y to the 8th. All right, now only one has an exponent to that term, to that group, that quantity. R to the 3rd, s to the 5th, 2 to the 6th, r to the 2 times 6, s to the 1 times 6. R to the 3rd, s to the 5th, 2 to the 6th. 32, 64. R to the 12th, s to the 6th. So 64, r to the 3 plus 12, s to the 5 plus 6. 64, r to the 15th, s to the 11th. No idea if all these are right. I haven't been checking against it. I'm just assuming that I'm doing it correctly. Let's look at number 30. 64, R15th, S11th. Yeah. I mean, if I'm not getting these right, I'm being quite the hypocrite. So that's square into that term, that square into that term. And now I'll make a mistake. We have the quantity of -2 to the second, a to the 2 times 2, b to the 1 times 2. We have the quantity of -4 squared, a to the 1 times 2, b to the 3 times 2. -2 squared is 4, a to the 4th, b to the 2nd. -4 squared is +16, a to the 2nd, b to the 6th. 4 times 16, 64, a to the 4 plus 2, b to the 2 plus 6. 64, a to the 6th, b to the 8th. Yep, just repetition, just getting it done, doing my practice. It's like free throws. Done free throws forever. But we just get it done because it's part of the practice. It's part of keeping us fresh. 2 to the 4th, p to the 3 times 4, q to the 1 times 4. -3 to the 3rd is -27, p to the 6th, q to the 12th. 2 to the 4th is 16, p to the 12th, q to the 4th. 16 times 27. That one, I don't know. 42, 12, 16, 7, 2, 2, 13, 432, -432. 27 times 16, 432. We have p to the 6 plus 12, q to the 12 plus 4, -432, p to the 18th, q to the 16th. Keep it going, baby. All right. A, we have to distribute. We're distributing this term into each of the terms inside the parentheses. So it's called the distributive property. And the reason why they do that is to see how you simplify each of those terms. So we notice, oh, I don't like that. That negative is not with the 5x to the 3rd. That negative is with the 1. Typically, I will write it in that fashion. That's the same thing as here. That negative is with the 6. That negative is with the 1, not with the 5x to the 3rd. We're distributing a positive 5x to the 3rd. So you will see me distributing the term into the terms. So I think that many books do a poor job of notating, proper notation. We're going to distribute x to the 2nd into each of these 3 terms. That is 7x to the 3rd. That's -x squared. That is positive 10x. And that is positive 8. So we will see each of those terms. X squared, 7x cubed, plus x squared, minus x squared, plus x squared, which we're distributing to 10x, plus x squared to 8. And we'll notice what we are distributing, the x squared, positive x squared. That sign in front of it's very important. We're distributing it to 7x cubed, to -x squared, to positive 10x, and to 8. And now we're going to multiply each of these products. Multiplication before addition. So 7x to the 2 plus 3, which is 7x to the 5th, negative x to the 2 plus 2, that's a positive 1 and a negative 1, which makes the negative, minus x to the 4th. Then we have plus 10x plus 10 x to the 2 plus 1, which is x to the third, and then plus 8x squared. Notice this expression is in standard form. It is descending order, x to the fifth, x to the fourth, x to the third, x to the second. That is the determinant, not the coefficient. Coefficient doesn't mean anything. So we have, this time we're distributing a negative. So we'll see the negative in each of the distribution things. Negative a to the third times negative 4a to the fourth minus a to the third times 5a cubed minus a cubed times 9a squared minus a cubed to negative a. See, it would be interesting to see what they did when you're distributing out a negative. Oh, here we go. Yeah, see, look at all these negatives. It's too confusing. That makes no sense. When do I keep it? Whoa, why didn't I distribute a negative here? Blah, blah, blah. It's horrible. It's a big contradictory. So my thing is, I always believed in looking at the term. What is the term we have? We have that term. That negative should stick with that term. That positive should stick with the term. Positive should stick with the term. And then this negative should stick with the term. And what are we distributing? We're distributing a negative a to the third. So we should see that negative next to the a to the third. So I'm a big stickler about that. Now we're going to multiply, which is positive 1, a to the third times a to the fourth. That's addition, a to the seventh. We have coefficients, which is negative 5, a to the 3 plus 3, negative 5a to the sixth. We have negative times 9, which is negative 9a to the third plus 2, negative 9a to the fifth. We have negative 1 times negative 1, which is positive 1a to the 3 plus 1, a to the fourth. We would never write 1 as a coefficient unless it's a constant coefficient of a variable. So notice we didn't write 1a to the seventh and we didn't write 1a to the fourth. So we can write it within our notes, but in our final answer we shouldn't have that. We're distributing a 3x squared to 5x squared and a positive 3x squared to a 3x and a positive 3x squared to a negative 2. 3 times 5 is 15, x to the 2 plus 2, 15x to the fourth. We have 3 times 3, which is 9, x squared plus 1, so 9x to the third. We have 3 times negative 2, which is negative 6x squared, negative 6x squared. No like terms. We've got nothing we can combine, and that would be our answer. Negative 8y times 2y to the fifth minus 8y, that's what we're distributing to our second term, which is negative 6y to the third, distributing a negative 8y to our third term, which is negative 3y squared. Negative 8 times 2 is negative 16, y to the 1 plus 5 is 6, plus 6 times 8 is 48, y to the 1 times y to the third is y to the fourth. Negative 8 times negative 3 is positive 24, y to the first times y to the second, which is y to the third. And we can get to that point where we don't have to write that middle line. We don't have to write this line because we can just go straight to that. We don't even have to write this line later on. You should be able to distribute that and simplify it in one fell swoop. Personally, you get x to the third y squared minus 5x to the second y to the third minus 2xy to the fourth. And that's what I'm talking about. Distributing and seeing what's combining, what's happening. And now they're in descending order by its leading variable, which is x to the third, x to the second, x to the first. Descending order based upon its leading variable. not its degree of each monomial. And the coefficient has nothing to do with it. So let's do it again. We'll do a to the 3. There you go. Already made a mistake. 3a to the 5th b squared minus 4a to the 4th b squared minus 2a to the 3rd b squared plus 3a squared b squared. A to the 5th, 4th, 3rd, 2nd. We're done. As fast and easy as that. Simplifying, assuming represent positive. Okay. Oh, yeah. Oh, well, variables. Yeah. Okay. So we still have like bases that we are multiplying. So what do we do with those exponents? Let's revert back. Just because it's a little bit more kooky and complex doesn't mean that we revert away. When we multiply like bases, we add their exponents. So we're going to add their exponents. T to the k plus 2. We're going to combine like terms in that exponent. So it's t to the k plus 2. We have like bases that we are multiplying. So we are going to add their exponents. P plus p is 2p plus 5. This is more Algebra 2 stuff where you maybe aren't familiar. So that's a to the t times 2 times a to the 3t. T times 2 is 2t times a to the 3t. Now we're multiplying like bases, so we are going to add their exponents. 2t plus 3t makes 5t, not 5t squared, because we're adding. We have an exponent that we're going to have to deal with first. So y to the 4th is unaffected. We have y to the 2m times 3, which is y to the 4th times y to the 6m. We have like bases and we're multiplying. So we are going to add those exponents. They are unlike terms, so we can't combine the 6m and the 4. And we would always write the variable before the constant. Like bases, we are multiplying. So we are going to add up all of those exponents. X to the 2m plus 1. Like variables, m and m make 2m, negative 2, positive 1. That'll be the differentiator. So if you're getting these right, you understand this. You're grasping this to a good level. So multiplication, like bases, adding their exponents, plus n plus 2 plus 4 minus 2n. So we get the n's cancel out, and we get n to the 9th, z to the 9th. Now that's a real weird one. Fact that you can end up with z to the 9th after all that other shenanigans, it's very interesting. All right, good worksheet. I mean, this'll tell you whether you're proficient or not. So excellent job. 8th graders, you should know this.